Okay, so for this next question, again, remember we are solving using completing the square method. We always have to set the equation equal to 0 first. So our first step would be adding 30 to both sides. And that cancels. So we're going to have 2x squared minus 16x plus 30 equals 0. Now here's a big caveat about solving quadratic equations using the completing the square method. You can only do so if, actually, hang on a second. I'm going to change something here. Okay, so here's the next question. Again, just to remind you, we are solving using completing the square method. As you know, we always move the constant to the right. Thankfully, that's already been done for us. The constant is already on the right side, so we don't have to do that step this time. However, the big problem is you can only complete the square when the leading coefficient is a 1. So we have a big problem because it's currently a 2. But don't worry, all you need to do is remember the first type of factoring, or rather the first factoring method we always look for is GCF. When you examine this closely, you'll notice, oh, wait a minute, 2 is the greatest common factor. So we can take that out, which leaves us with x squared minus 8x equals negative 30. And then next, we're going to have to get rid of this 2, and we can do so by dividing both sides by 2, like that. So now let's proceed. These twos are going to cancel, of course. So you'll now have x squared minus 8x. You can add that blank now, equals negative 15 plus the blank. The negative 15 came from this negative 30 divided by 2. Okay, so remember, to fill those blanks, you always do b over 2 squared. So b value here is 8. So 8 divided by 2 is 4. 4 squared is 16. So we have a 16 over here and a 16 right there. We're just going to continue working this out. The right side, again, is easy. It's negative 15 plus 16. That's just going to be a 1. On the left side, remember what we said. These are always factoring neatly. So you can always set up a parenthesis squared. You always copy the first sign. So this time it's a negative, so it's going to be a minus in here. And then you fill the blanks here by taking the square root of that first term and the square root of that last term. So that's going to be x, and this is going to be a 4. And then, since we're solving, the next thing we need to do is take the square root of both sides. Square root like that. And now you have x minus 4 equals plus or minus 1. Last but not least, you're going to add 4 to both sides. We have x equals 4 plus or minus 1. So x equals 5 and x equals 3. Those are the two solutions to that problem. Okay, so these two also require you to use the same method, completing the square. So we need to move the same process, folks. We need to move the constant to the right. So start off by adding 42 to both sides. Now those, of course, cancel. We end up having 3x to the second minus 18x equals 48. Another big problem, we cannot complete the square unless the leading coefficient is a 1. Thankfully, when you look at these, we have a greatest common factor of 3, which means we can take out a 3, factor out a 3, which leaves you with x squared minus 6x equals 48. But again, we are lucky because we can actually get rid of this 3 by dividing both sides by 3. So now our equation, of course, those 3's cancel. So our equation is now x squared minus 6x. Look, I'm going to leave that blank now, equals 16 plus blank. 48 divided by 3 is 16. Okay, so how do we fill the blanks? At this point, I'm sure you guys already remember this. You always say b over 2 squared. So our b value is a 6. 6 divided by 2 is 9. Is 3. 3 squared is 9. So 9 there and 9 here. And we just proceed. The right side is the easier one, so we just go ahead and add these two together. 16 plus 9 is 25. The left side factors neatly every single time, so that's going to be something squared. Always copy that first sign. It's a negative. Fill the blanks with the square root of the first term and the square root of the last term. Very good. Now we're going to go ahead and try to solve for x. Square root both sides. So we end up having x minus 3 equals plus or minus 5. To finish this off, you're going to add 3 to both sides like that. So those are gone. So x equals 3 plus or minus 5. But we can actually finish this off by saying x equals 8 because 3 plus 5 is 8. And x equals negative 2 because 3 minus 5 is negative 2. Those are the answers to question 25. So the next question, question 26. Same process. Move the constant to the right. Start off by adding 83 to both sides. Those are gone. The left side, they have a 10 in common. I'm going to factor it out. We have x squared minus 2 equals positive 80. Next step is divide both sides by 10. So what do we now have? X minus 2x plus blank equals 8 plus blank. Oh, I forgot the x here. I'm sorry. That should be 2x, not just a 2. So now let's fill the blanks using b over 2 squared. So b is a 2 this time. 2 divided by 2 is 1. 1 squared is 1. So 1 and 1. The right side is the easier one. So 8 plus 1 is 9. The left side always factors neatly. We have a minus in between them. I forgot the x squared. What am I doing? I forgot the x squared there. I'm so sorry, folks. Catch up with me on this. And then we use the square root of that first term. It's going to be an x. The square root of 1 is just 1. And then the last thing we're going to do is square root here, square root there. So we then have x minus 1 equals plus or minus 3. So I'm adding 1 here, adding 1 there. Those are gone. So x equals 1 plus or minus 3. But of course, this is workable. So x equals 1 plus 3, which is a 4. And x equals 1 minus 3, which is a negative 2. And those are your two solutions to that question. So moving on to the next concept. Here, it's simplifying exponents. Oh, so we need exponent rules. It says simplify each expression and state the rule used or rules used. So the multiplication property, remember, if you're multiplying numbers that have the same base, all these have the base of f, you keep the base and you literally just add the exponents. So again, if you're multiplying numbers that have the same base, and yes, these are being multiplied, you keep the base and you add the exponent. So it'd be negative 3 plus 2 plus negative 3. Let's simplify this. Negative 3 plus 2 is negative 1. Negative 1 minus 3 is negative 4. So please remember, never leave your answer with a negative exponent. That's going to be marked wrong always. Thankfully, to fix this is super easy. You simply move the thing that has the negative exponent. But first, let me remind you guys, there's an invisible 1 underneath this. So it's really this is f to the negative 4 over 1. So you're going to have to move this entire thing to the denominator. And when you do that, it's going to make the negative exponent a positive. So you will have 1 over f to the power 4. So you don't leave the numerator blank. So this should be your answer to this question. But now we can state the rules. So the first rule we used is the product rule. Product rule, because we applied it here. And then the second rule we've used is the negative exponents rule. So those two. Okay, question 28. Let's continue with this. I'm going to draw a line here so this is not confusing. All right, so remember, it looks like you have a lot going on, but this is pretty simple if you just focus on like terms. So just focus on the numbers alone. We have 2s, then we have A's, then we have B's, and we have C's. So we'll just consider one thing at a time. So don't be overwhelmed by this, one thing at a time. Starting with a negative 2 divided by 2, well, that's just going to be a negative 1. Simplify this fraction, negative 2, just simple math. Negative 2 divided by 2 is negative 1. Okay, so moving on to the a values. So we have a squared divided by a squared. In this case, we have, if you have the same base and we have the same base with a's and they're being divided, you simply subtract the 2. subtract the bottom one from the top one. So it would be a to the 2 minus 2. Then we can move on to the b's, right? B's here, again, they have the same base, so you keep the base, and you subtract the bottom one from the top one. Now we're going to move on to c's. And by the way, there's an easier way to do this, but I'm showing every step like this so I don't lose some of you guys. Keep the base is c, 0 minus 7. You subtract the bottom one from the top one. And now let's simplify this entire thing. We have a negative 1 still. A to the 2 minus 2, that's going to be a to the power of 0. And then b to the first, because 3 minus 2 is 1. And then c to the negative 7. I'm taking a longer route, y'all. So if you're able to do this in fewer steps, that's great. I'm only showing every step because I know I might lose a few of you guys. Anything to the power of 0, right, is a 1. So we know that this is really just going to be a 1. I usually just scratch that out. So we have a negative b. And remember, you're not allowed to have a negative exponent. So that is going to need to come to the bottom. So it'll be c to the power of 7 as our final answer. So what rules did we use? We use the quotient rule. We used the 0, which is power of 0. You guys might have to look at how you phrase these. There's a cheat sheet that I think your teacher gave you, Miss Palmer. So refer to that. And we use the negative exponents rule. Negative exponents rule. Could we have done this quicker? Yes. But I'm going to just have you guys do it this way. If you have a quicker method, but it yields the same answer, more power to you. Keep doing that. Okay. The next section is asking you to write equations in standard form. Now, what does that mean? Standard form means you have to start with the highest exponent. Write those numbers first. And then you go down to the smallest exponent or lowest exponent. So when we look at a question like this, the highest degree or highest exponent is x squared. So I'm going to say negative x to the second. Yes, you have to look at the sign that's right before that value. Minus 5xy plus 14y. The xy will take precedence because he has an x. So yeah, that would have to be it. Question 30. Highest degree here is x to the fourth. So we'll start with that term. So 2x to the fourth power. The next one down is plus 10x to the third. The next one is plus 4x. And then a minus 1. This one is already in standard form. So is this. Is that all we were doing? Oh, we're writing in standard form if needed, and then classify. I missed that second step. So folks, we have to classify the polynomial. So we classify polynomials by degree and by the number of terms. So if the degree is 2, this is quadratic. You guys have notes on this already. This is by degree, this is a quadratic. And it has 3 terms, 1, 2, 3 terms, which makes it a trinomial. So this is a quadratic trinomial. You always do degree and the number of terms. So here, by degree to the fourth power, that's called quartic. And it has 4 terms. So remember, if you have 4 terms, I think we said quadrinomial. But some of you told me that you guys, after 3 terms, you just say polynomial. So it could be that. Or we could say quartic polynomial. Both of these are correct. For those people who told me that you don't have to say the specific term after 3 terms, you can use polynomial. But for those people who want to be even more specific, use the term quadrinomial. That means you have 4 terms, 1, 2, 3, 4 terms. Okay, the next one. The highest degree is 3. That's called cubic. And it has 2 terms, binomial, cubic binomial. The next one, 1 term, and the degree is 1. So this is a linear, because degree is 1, and 1 term is monomial. Well, that completes that section, and this is straight up from your notes. So just study your notes also. The next section is requiring us to simplify polynomials. So let's go there. We're just adding polynomials. This is a matter of combining like terms. I'm noticing a squared and a squared right there. Just color code these real quick. And then I'm noticing a -6 and a 1 right here. And then I'm noticing a plain old -8a and a -6a like that. So we just combine like terms. And the answers must be written in standard form. That's what the instructions are saying. So let's start with the highest degree. 8a squared minus 7a squared. That's going to be 1a squared. So there's no need of showing the 1. It's okay. Just say a squared. It makes you look more professional. The next degree is the green, which is -8a minus 6a. So -8 minus 6 is -14a. And the last but not least are the constants. And those are -6 plus 1, which makes it a -5. So our final answer, I'm just going to make it one color so it's not so festive. You have a squared minus 14a minus 5. This 2 looks weird. Let me fix that. There you go. Now remember, when you're adding two polynomials, life is pretty straightforward. However, when you're subtracting, you want to be a lot more careful because this subtraction symbol is affecting all of these numbers after it. All the signs are going to be changed. The reason is you're distributing a 1, like -1 times 5. So this will end up being -5x to the second. This will end up being -2x plus 2x cubed plus 1. I'm just going to bring down the first one because nothing changed there. So 6x minus 7x squared plus 7. And now we combine like terms. Again, remember, just since we have to write this in standard form, why don't we just do it now. We have 2x to the third as our highest degree. So I'm going to write that first, 2x to the third. That means we've taken care of this one. And then the next one on our list is 5x squared. So we have -7x squared. Sorry, -7x squared minus 5x squared. That's a -12x squared. That covers this one and that one. The next thing on our agenda is the 6x minus 2x. That becomes a 4x. So these are gone, taken care of. And then we have a 7 plus 1. So that makes it an 8. And there you have your answer. Oh, I forgot to box the one above it. Let me go ahead and do that. Okay. Moving right along. Still simplifying polynomials. This is multiplication. And again, always write your answers out in standard form. So this is pretty much distributing again. You take the 3y, multiply each of these terms in the second parenthesis by it. Once you've done that, you're going to come back and do the other guy. This times all of these guys. All right. So let's finish this. I'm going to use this color. 3y times y squared is 3y to the third. 3y times -y is -3y to the second. 3y times 7 is 21y. And then -6 times y squared is -6y to the second. -6 times -y is +6y. -6 times 7 is -42. And then, of course, you examine to look to make sure that you don't have any like terms. If you do have like terms, then you want to combine them, of course, right? So do we have like terms? We do have like terms. These. Okay, let me color code this again for you. We have the 21y. And that's about it. Let's combine those. So our answer will end up being 3y cubed. -3 minus 6 is -9y squared. 21y plus 6y is 27y. And then you have a -42 at the end. And that is your answer in standard form. Good stuff, y'all. Keep going. So here we're once again distributing. So -3x times 5x, -3 times the 1. So this becomes -15x squared minus 3x as our first parenthesis. And then there's another one, 8 minus 2x. Now we're going to have to FOIL here. So we're going to take this times this times that. Once we've done that, we'll then come back and do this part. This times this times that. Let's do the orange ones first. Negative 15x to the second times 8 is negative 90x to the second. Negative 15. Oh, I'm so sorry. Negative 15 times 8 is not 90. My apologies. That should be 120, right? Yeah. Sorry, let me change that. This is going to be negative 120 x to the second. And then negative 15 x squared times the negative 2 is a positive 30 x to the third. And let's do the purple ones. Negative 3x times 8 is negative 24x. Negative 3x times negative 2x is positive 6x to the second. Again, we're at the point where we need to combine like terms. Notice this guy here and that guy are both x squared, so those are like terms. We need to combine them. So, but it has to be in standard form. So I'm going to write the 30 x to the third first. Negative 120 x squared plus 6x squared is negative 114 x to the second. And then minus 24x. Standard form. Okay, question 37. This is x minus 2 to the fifth power. This, please don't make the silly mistake, the common mistake that everyone makes and thinks that says x to the fifth minus 2 to the fifth. Do not do that at all. That would be incorrect. What this is saying is we need to do x minus 2 times x minus 2 times x minus 2 times x minus 2 times x minus 2. But if you're thinking that's going to be incredibly difficult to do all this, to multiply all these binomials, you're right. There has to be a better method because this is near impossible to keep track. You would probably fill out this whole space and it would be a lot of work with a lot of room for making mistakes. Enter Pascal's triangle. This is why we were making Pascal's triangle, to expand these binomials. And I'm going to draw it, the Pascal's triangle, at this corner here, so we have room to work the actual question out. Remember, it starts with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. I'm stopping at 5, this row, because our degree is 5. So we need that last row. So that last row, remember, is these are going to be our coefficients. So we write them down, but we space them out. So I'm going to start with 1, 5, 10, 10, 5, and 1. And then remember what we were doing? We take this first item, the first term in this binomial is an x, and we start with that high. So x to the fifth, x to the fourth, and we bring it downwards. X to the third, x to the second, x to the power of 1, and finally x to the power of 0. And then we are going to take that second term, which is a negative 2. Yes, you have to keep that sign, folks. Very, very important. And because it's a negative number, you have to put it in parentheses. So that second term, you started low. So you started at 0. And then it's going to keep going up. So to the power of 1, negative 2, to the power of 2, negative 2, to the power of 3, negative 2, to the power of 4, and finally, negative 2 to the power of 5. The rest is just simplifying, just simple arithmetic. First things first, I like getting rid of anything that's to the power of 0, because that's just going to be a 1. So I'm going to scratch that out, and I'm going to scratch out the x to the 0 here at this end. The rest is simplification, folks. 1 times x to the fifth. Oh, that's just going to be x to the fifth power. 5 times negative 2. So you have to do these digits first. 5 times negative 2 to the power of 1. So that's really 5 times negative 2, which becomes a minus 10 x to the fourth power. The next one, 10 times negative 2 to the second. So that's really 10 times 4. And that's going to be a positive 40 x to the third. And then next we have negative 2 to the third. That's negative 8. 10 times negative 8 becomes negative 80 x to the second power. And next, 5 times negative 2 to the fourth. Well, negative 2 to the fourth is 16. 5 times 16 is 80, 80x. And then last but not least, we have 1 times negative 2 to the fifth. Negative 2 to the fifth is negative 32. Is it 16 times 5 really 30? It is. I don't know why I'm having a hard time remembering that or figuring it out. Anywho, this would be the answer to the question 37. I know this is a lot, but you might have to pause this video, come back and try this problem again. Now, if you want to do more research and do more practice problems, you can just go to YouTube and type in binomial expansion and just watch some videos if you need more videos, or look at your notes. Alrighty, next question. Simplify the polynomial by dividing by a monomial, factoring, or a long division. Final answers should be written in standard form. Okay, got it, bet. So if you have a monomial, the best approach here is to really rewrite this by giving each one that denominator of that monomial. So 12r to the fifth divided by 4r to the fourth plus 4r to the third divided by 4r to the fourth plus 48r to the second divided by 4r to the fourth power. Now, just simplify each fraction individually. So starting with this, 12 divided by 4. Oh, that's just a 3, right? And then r to the fifth divided by r to the fourth. Remember, you keep the base. And the rule says if you're dividing, subtract the exponents. And you subtract 5 minus 4 will be just r to the power of 1. But if it's to the power of 1, is there a point of me showing the 1 there? I wouldn't even bother. Just leave it alone. Okay, go to the next one. 4 divided by 4. That's just going to be a 1, right? And then we have 3 r's up here and 4 r's on the bottom. So I can say these 3 r's cancel out and they cancel 3 r's on the bottom. So really we're left with an r on the bottom, 1 over r. I know that kind of looks weird. I'm giving you multiple ways of doing this. Let me just expand this and explain it a little bit. I'm going to expand this part here. R to the third over R to the fourth, right? This is a different way of thinking about this. R times R times R is what the top is saying. The bottom, we have 4 of them. So what I'm trying to share with you guys is you can actually logically see that you have 1 up here and an R on the bottom. That's why we have this. Alternatively, remember the rule that says, oh, guess what? If you have 2 numbers that have the same base, the base is R, and they're being divided, you keep the base and you subtract the bottom one from the top one, which gives us r to the power of negative 1. But wait, we cannot have a negative exponent, so we have to fix that by moving it to the bottom. So it becomes 1 over r. Again, the same thing as this. So there are multiple ways of arriving at the same answer. I'm giving you different ways of thinking about this so you're better prepared. But if you have a method that works for you and you get the question right 100% of the time, well, stick to that. Here's the next question. 48 divided by 4, that's going to be a 12. We have 2 r's up here and 4 r's down here, which means the 2 r's up top can cancel the 2 r's on the bottom. So you'd have, oh, I forgot, you'd have a 12 over r squared. And that is the answer to this question. All right. All right. Oh, actually, wait, it did say write the answer in standard form. So because this one has r squared, let's rewrite this and have it at the beginning. So we would say this is 12 over r squared plus 3r plus 1 over r. I don't think you get dinged for writing it this way either, but just to be safe. Okay, y'all. Now, are we told to use any specific method? It just says use any method, huh? So what would be the best method for dividing this one? If I were you, we can use long division here. I know you guys are not fans of the long division, but we can use long division here. So I'm going to write it as x to the second minus 7x plus 10. You can divide that into 9x minus 45. So folks, remember the goal is always to get rid of that first term. I'm not a fan of this at all, to be honest with you guys. Can we change this out? Let me make a suggestion here. I'm going to change strategies. I don't like the long division. If it's okay with you all, let's use synthetic division for this question. So let's change this to synthetic division. Now, when you're dividing by synthetic division, what you put out here, this number is you got to solve for x in this little divisor. So we have 9x minus 45. We need to solve for x. So set it equal to 0. Add 45 to both sides. So 9x equals 45. X ends up being a 5. That's what you're going to put out here as your divisor. Okay, and then in here, folks, remember we were filling this space with the coefficients of this equation. So the coefficients are 1, -7, and then 10. And as a reminder, if you're missing a power, like let's say we didn't have this, you would have to put a 0 there as a placeholder. Anything that's missing, you have to put a 0, just a reminder. This time we're not missing anything because it's x to the power of 2 to the power of 1, so we're good here. I'm going to bring back the -7 as it should be. Great. I hope you understand that. Once you've set it up, the first step is moving down. Just drop down the 1. The first digit, always drop it down directly. And then you always multiply these. 5 times 1 is going to be a 5. And then you're always adding downward, right? So it'd be -7 plus 5 is a -2. And now again, we're back to multiplying for the next one. 5 times -2 is a -10. Oh, and then again, you're adding these. 10 plus -10 really just cancels out. And I box out the last thing on here because that's like your remainder. And these numbers are your new coefficients. So this new coefficient is x minus 2. Remember, when you divide, you're dropping the degree by 1. The degree used to be a 2. Oh, so it has to go down to just having a degree of 1, just as a reminder. So your answer to this question is x minus 2. That's done. So question 40, once again, I'm going to suggest that we use the synthetic division method again. So we draw the L. What in the world are we going to be dividing by out here? Remember, you take your divisor and you have to solve for it. So y minus 7 equals 0. Add 7 to both sides. So we're going to be dividing by is 7. And then the coefficients go here. So the coefficient 1, and then -7, and then -2, and then 18. We are not missing anything. Oh, we are missing something. To the power of 4, to the power of 3. Where's to the power of 2? That's missing. So we need to put a placeholder for the power of 2. We do have the power of 1, so that's going to be -2. And then we have the constant, which is 18. So then, as is custom, we're going to drop down the first digit right there. Let me write the 7 better. And you're going to multiply. 7 times 1 is 7. You're going to add these. You get a 0. 7 times 0, 0. 0 plus 0, 0. 7 times 0, 0. -2 plus 0, it's -2. 7 times -2, -14. 18 minus 14 is 4. Again, always box off the last digit. This is your remainder. So now we got to write the new equation, right? Remember, after dividing, you drop the degree by 1. We started with a y to the 4th. So now the coefficients are 1y to the 3rd plus 0y squared plus 0y minus 2. But is there really a point of showing these? That's kind of silly for me to write this. I'm just going to eliminate those. And we're going to write the answer out as y cubed minus 2. Now, wait, sorry, we have a remainder for this problem. So here's what you do with the remainder. You attach it to your answer here. Since it's a positive 4, I'm going to say plus 4 over your divisor, which is y minus 7. This is the full answer to that question. Okay, so moving right along, folks. Given this equation and that equation, this is function notation. We are asked to find, we're given 3 equations, h of x, three functions. The first question is subtract f and g. Simple as that. You're going to take the function f, which is x squared minus 4x minus 12, and you're subtracting the function g. Now, because this is a subtraction, you want to be incredibly careful. You must enclose the second one in parentheses. Why? Because remember, this negative affects the signs in here. If had it been a plus, we wouldn't have cared. But because it's a negative, they're being subtracted, we have to really watch out for that. So here we'll end up having negative 5x to the second plus 2. Then we'll have x squared minus 4x minus 12. I just brought this down because nothing changed. Now it's just a matter of combining like terms. X squared minus 5x squared, negative 4 squared. And then minus 4x is just by itself, so I'm going to bring it down. We have a negative 12 plus 2. That's a negative 10. And you are done with that problem. Simple as that. So just obey what this is telling you to do. That's inviting you to just subtract g from f. The next question is asking you to multiply h to g. H and g multiplied. So h is x plus 7. So I'm going to put that in parentheses because you're multiplying. And then g is 5x squared minus 2. So this is calling for foiling, right? So we got to foil this guy. This times this times this. And then once we've completed that, we're going to come back and do this times this times that. And then we're going to combine like terms if we have any. X times 5x squared becomes 5x to the third. X times negative 2 is negative 2x. 7 times 5x squared is 35. X to the second. 7 times negative 2 is negative 14. We don't have like terms, but we need to write this answer in standard form. So from the highest degree, followed by the second highest, third highest, and finish with a constant. And that, friends, is your answer to this question. Okay, this is the same idea, really, folks. We're being asked to now divide h and f. So function h is x plus 7 divided by function f, which is x squared plus 4x minus 12. So typically, you are supposed to simplify these if you can, but let's see if we are able to do that. So focusing on the denominator, is it factorable? Let's see. We can do a product. It's negative 12. Sum is what? 4. What multiplies to negative 12 and adds to 4? You might be thinking, oh yeah, 6 and a 2, but I would have to make the 2 a negative. So let's see if anything simplifies here. We have x plus 7 on top, but the denominator is x plus 6 and x minus 2. So nothing canceled out. Sometimes you find stuff canceling. This time it doesn't happen. That's why I was doing that. So I think you should check it to see if you can or not. So we could have left the answer here. But since we simplified, there's no harm in doing the simplification. So you're good. That's still right. Question 44, pretty self-explanatory. It's telling you to just add g to f, right? So you have 5x to the second minus 2 plus h of x is x plus 7. And because we are adding, we don't need to be careful here with parentheses. That doesn't matter. It only matters when you're subtracting because the negative affects everything. Here we only have two like terms, so let's go there. 5x squared plus x plus 5, because negative 2 plus 7 is 5. Done. Okay, so now we're getting closer and closer to the more challenging questions, or the more fun ones, if you like. You notice we have f minus g of negative 2. That's how you read this. F minus g of negative 2. This is a two-step process. You want to do f minus g first, which I believe we did up here. Did we not do f minus g? We did do f minus g. So we can literally steal this thing, but let's just rework it. And then once we have f minus g, we're going to plug in a negative 2 into it. So f is x squared. Oops. X squared plus 4x minus 12. Again, folks, remember, This is a subtraction. So you want to be extremely careful and put the second parenthesis, put the second term in parentheses. You're subtracting g from it. So we're subtracting 5x squared minus 2. So let's open up these parentheses. Negative 5x squared plus 2. And here you have x squared plus 4x minus 12. I'm just bringing that down. Let's keep working this out. We have like terms. X minus 5x squared is a negative 4x to the second plus 4x. Negative 12 plus 2 is a negative 10. So that's this part. But remember, this is a two-step problem. Once you've done that, it's telling you, give me that of negative 2, which simply is fancy language for plugging negative 2 into all your x values. So this will be negative 4, plug into the net negative 2 squared, plus 4 times negative 2 minus 10. Again, these are instructions. Do that first and then plug in the number next to it once you've done this, the first part. So using algebra, I'll just plug this into your calculator. This will be negative 4 times 4 minus 8 minus 10. So negative 16 minus 8 minus 10. Negative 24 minus 10 is negative 34 as your final answer. Okay, so again, like I said, we could have just taken what we already had done f minus g. See this part right here? We had already done that. Let me prove it to you. I'm going to zoom out a little bit here. You'll see f minus g that we got from above. Oh, it's too far up. This f minus g is the same as that. Those are the same. So we could have not done the work twice. In fact, let's see. Have we done the next one? H over g? We haven't done h over g. I was going to just steal it, but we haven't done h over g yet. Anywho, let me zoom back out. And put back in, I should say. Okay, so 46, h over g. We'll do this part first, and then once we've done it, we'll do the 4 next. Is it the only way to do it? No, there's another way to do it, but let's just do that because I think it made sense to you when we worked together. All right. If you're wondering what's the other way you could do this, rather than do h over g first, you could literally plug in f4 into h first, and then plug in f4 into g first, and then simplify those values. But let's just do h over g. All right, so h is x plus 7 over g, which is 5x squared minus 2. Now, it says once you've done that, plug in a 4 into all the x values. So this will become 4 plus 7 over 5 times 4 squared minus 2. Again, simple math, simple arithmetic here. What's 4 plus 7? The top is 11. 5 times 4 squared, that's 80. Minus 2 is 78. 11 over 78. So the way to write the answer right, actually, let me be honest, is h over g of 4 equals this value. That's really how I should write these answers. Do I think Miss Palmer would be upset if you don't? I don't think so. But to be safe, I'm actually going to fix 45 also. I'm going to write the answer in its correct syntax. So it should be f minus g of negative 2 equals negative 4. There you have it. Okay, so we're making good progress. The next section is still on function notation. And these are known as, just composition of functions. Sounds fancy, pretty simple. See how you have f of g of x? These are instructions. It says you're going to take the function g and you're going to plug it into f. Anywhere there's an x value, you're going to plug in that function. So let me show you this in a better way. So you're going to take these values, g of x, and you're going to plug them into every x into that equation. So that's what we're doing. So for this guy, where we have an x, we have replaced the x with a 4x minus 9. Since that's squared, because that's x squared. We replace the x with the 4x minus 9 squared plus a 4. And then we have to simplify this by saying, 4x minus 9 squared means we have to write it twice, because that's what you do when you square a number. And then we're going to FOIL it out. So when you FOIL this out, you will have this times this, this times this. So I'm trusting you guys remember how to FOIL, but that's going to be 16x to the second minus 36 minus 36. So that's going to be a minus 72x plus 81. I skipped a step because I know you guys know how to FOIL. If you don't know how to FOIL, go to YouTube and just Google how to FOIL. And I hope you know how to FOIL, because if we don't, we're in trouble. At this point in the game, we got to be proficient in foiling. It needs to be like a fundamental skill that we just know. All right, so we go to 16x to the second minus 72x. These are like terms, so I'm going to combine them. It's just going to be 85. So f of g of x is this answer. Good. All right, so let's move along, folks. You can write these composition in two ways. This is method 1. This is method 2. They mean the same thing. You can these again, just like the instructions were to take the g and plug it into f. That's the same exact instruction here, but this time he's saying take h, dump it into g. So let me show you that. We're going to take h and we're going to dump it into g right there. So that's going to be 4. In place of x, we are putting in x squared plus 3x minus 10. And then there's a minus 9. This minus 9 right there. So let's distribute the 4. This becomes 4x squared plus 12x minus 40 minus 9. We do have like terms. So g of h of x equals 4x squared plus 12x minus 49, because those two combined give you a negative 49. And that's the answer, folks. Okay, let's keep going. The next section has the same style, same instructions, just one more step. It's like a 2-step question. And once again, I'm going to keep explaining this, folks, for those who need it. You take f, that's the instruction, plug it into g. And then once you've done that, you're going to take the negative 3 and you're going to plug it into that equation, whatever that's going to be. So let's do it in steps. So let's take the function f, this guy here. Oops. Take f, and we're dumping it into g, where there's an x right there. So we'll have 4, open parenthesis, x squared plus 4 minus 9. This is part 1. Okay, so then let's simplify it. Okay, so 4x squared plus 16 minus 9. That comes from me distributing this 4. And then we can simplify this further, because the 16 and the 9 are like terms. We end up having 4x squared plus 7. Now that's part 1. The second part was saying once you have that, we just did this part. Once you have it, then you plug in this negative 3 into it. So now we're taking the negative 3 and putting it in place of x. Okay, so 2 steps. So we have 4. Now we're plugging in the negative 3 in there, squared plus 7. This becomes, you can use your calculator for this. 4 times 9 is 36 plus 7. This becomes 43. But to write the answer in the correct syntax, I'm going to say g of f of negative 3 equals 43. I'm thinking you're okay if you just write 43, but I'm just being extra cautious here. Okay, so enter question 50. So if you see these nested ones, again, multi-step problems, work from the inside out. What this is giving you instructions to do, you're going to take 7, you're going to dump 7 into h. That's going to give us some number. We'll take that number and we'll dump it into g. So 2 steps. Work with me on this. Take the 7, let's dump it into h. So anywhere there's an x, we're putting in a 7 in this function right here. So we have 7 squared plus 3 times 7 minus 10. So we have 49 plus 21, subtract 10. This is going to be 70 minus 10, and that's going to be 60. So that's h of 7. We finished this part right here. So now this is a 40. We're taking the 40 and dumping it into the function g. So we'll take 40 and dump it in here. I mean, sorry, it's not a 40, it's 60. Our answer was a 60, not a 40. My apologies. 60. So it'd be 4. Yeah, we're taking 60 and dumping it into G. 4 times 60 minus 9. So we have 240, take away 9. So our answer for G of H of 7 equals 200 and, is it 31? 31. Just two-step process. Okay, now we enter into factoring, another exciting section or type of problem that we've been working on. So let's see. So many methods of factoring, but folks, I know you're tired of you hearing me say this, but the first and most important and the most basic form of factoring is looking for GCF. When I look at these two numbers, I can determine that they have a greatest common factor. What goes into both of these? A 2. 2 is a GCF, so I can take out a 2, which leaves us with a 16x to the 6th minus 49y to the 2nd. So once you take out a GCF, and you don't always have a GCF, you may not have it, but you should always look for it. Then there were other methods, right? We talked about using the X method. This is when you have, a trinomial that is, with an even degree. Then we talked about grouping, and we were using grouping when you have 4 terms. Then there are the special cases, like the difference of squares. We called it dots, difference of 2 squares. This is when you have a binomial with a subtraction and 2 values that have a square root, which is what we're looking at for number 51. There's a subtraction on this binomial, and both of these have a square root. The square root of 16x to the 6th is 4x to the 3rd. The square root of 49y to the 2nd is 7y. You guys remember this? I hope you do. So now, once you know that we have a dots, we know that we always have 2 parentheses. One of them always has a plus, the other one always has a minus. So now we just fill the blanks with the square roots that you just found. So this is 4x to the 3rd and 7y. 4x to the 3rd and 7y. And there's no place else to go. So that's fully factored. You may have to pause this and watch it several times. Again, if you find that you need more practice or more review, go to YouTube and type in difference of 2 squares or factoring difference of 2 squares. Then watch a couple videos there to be really proficient. Okay, so looking at the question 52, how many terms do we have, folks? 1, 2, 3, 4. And we just said if you have 4 terms, which method do we use? Use grouping if you have 4 terms. Okay, how do you group? Literally set each pair in its own parenthesis, like that. And now you focus on each parenthesis and you take out the greatest common factor. So for this first one, x squared is the greatest common factor, leaves you with an x plus 2. The second one, 5 is the greatest common factor, x plus 2. For those who have a really good memory, you may remember that you always want the 2 parentheses to be the same. Okay, if they're not the same and you use grouping, that means something went wrong. Go back and fix it. But since we are good here, all you do is see these 2 outside terms, you're going to put them in their own parentheses. So x squared plus 5 in its own parenthesis, and x plus 2. You just write down one of the 2 that are the same, and that's it. And I said plus 5, by the way, because this is a positive right here. Had this been a negative, then I would have said minus 5. All right, there are other factoring methods that I didn't mention up here. A 5th method of factoring that we looked at was sum and difference of cubes. Difference of cubes. When do you use this? When you have perfect cubes. These are numbers that have cube roots. And this is where, folks, we brought in SOAP and SMS to help us remember this. Okay, I only bring this up because 53, question 53 needs it. I'm going to hide this 53 because it's sort of like in that way. It's sort of like confusing, but this is question 53. Just know that I'm just blocking it out because it's not part of the problem. And I don't want you guys to get confused by that. So does x cubed have a cube root? If you've answered yes, you are correct. The cube root of x cubed is just x. Does 512 have a cube root? If you've answered yes, you are correct. And I think the cube root of 512 is 8. So this is a sum of cubes. Now, for those who may have forgotten, let me write down the sum of cubes up here, sum and difference of cubes. So let's say we have a cubed, something that has a cube root, plus another thing that has a cube root. We said, which is what we're looking at here. That's this example. We said it factors like this. It's always going to be a binomial then and a trinomial. Let's talk about the signs. We use SOAP to help us remember the signs that go in those parentheses. S stands for same. O stands for opposite. AP is always positive. So same sign. So this means it has to be a plus. Opposite, and then always positive. That helps you. SOAP is for helping you remember those signs. And then SMS helps you remember the second parenthesis. You have to square, multiply, square, square, multiply, square. But now that we've gotten this far, I want you to remember that the blanks, you take the cube roots and you put them in here. This is squared, multiplied, squared. So what I'm trying to show you guys here in essence, this is your A value and that's your B value. You've already found your A and B. So let's actually finish this question. We know that we have a binomial and we have a trinomial. It's a positive, so same sign, opposite sign, always positive. So this will be x and 8 squared multiplied squared, because 8 times 8 is 64. And that is the end of this question. You cannot go further. We're just being asked a factor, so we'll stop there. That's it. While we're at this, we've talked about the sum of cubes. What about the difference of cubes? A cubed minus b cubed. Again, same rule, a binomial, a trinomial. Same sign, squared, opposite sign, multiplied, always positive. Simple as that, folks. So now we're moving on to question 54. And we have 4 terms, which calls for which method, folks? 4 terms you use, grouping. So if you've said grouping, great job. Again, let me get rid of this 54 just so it's not in the way. It's not part of the problem. It's just the number of the problem. Okay, we've grouped. We have 4 terms used grouping. Take out the GCF in this first parenthesis. X squared is what they have in common, which leaves us with a 2x minus 3. Second parenthesis, we have a negative 32 and a 48. The GCF there is negative 16. So you have a 2x minus 3. Again, notice how my 2 parentheses are exactly the same as they should be. This 2x minus 3, same as that 2x minus 3. And if you're in doubt, oh, you can just do a quick check. Negative 16 times 2x, oh, that gives me the negative 32 that I wanted. Negative 16 times negative 3, oh, that gives me the 48 that I wanted. So we know that it works. And the next step, remember, is just taking the 2 terms that are on the outside and giving them their own parentheses. So x squared minus 16, you put those together. And then you have a 2x minus 3. But folks, be careful because it may appear as though you've finished the problem, but you haven't yet until you've examined to see if you can factor further. For those who have a keen eye, you'll notice, oh, this can factor further. That's a difference of 2 squares, which means we can do the dots basically, which means open two parentheses, x plus 4, x minus 4. And then I'm going to bring down the 2x minus 3 because we can't go any further with it. That, folks, is fully factored. Now, while we're here, I'm just remembering that sometimes we're asked to factor and solve. So yeah, you would do the same exact thing. Solving, as a reminder, folks, we're not doing it for this problem, but I just want to mention this. You go one extra step. You set each of these equal to 0, and then you solve, which I'm pretty sure that might be the next section. Actually, let's just go there. Let's go there and see if that's what the case is. Well, yes, it's going to be in this section coming up soon. So now you know. Same idea, just Make sure you are taking that extra step. All right, so this question, we have to factor. Again, always look for GCF first. We do have a GCF. 6 goes in all of them, so I'm going to take that out. 8. And then you focus on what's inside of the parentheses. Oh, it's a trinomial and it's even. So this calls for the X method, folks. Product and sum. What multiplies to -8 and adds to -2? So if you've said 4 and 2, you're on the right track. But what signs do we need? 4 times 2 is a positive 8. We wanted a -8. 4 plus 2 is a positive 6. So we have to make this 4 and negative. Let's see if it works. -4 times 2 gives us the -8 we wanted. -4 plus 2 gives us the -2 that we wanted. So we know these are our terms. So now we can write this out. It'll be, oh, keep the 6 that you factored out. It's part of your factors. And now your two parentheses will have x minus 4 and x plus 2. Those are fully factored. Okay, now we are solving these. Once again, solving, you have to set your equations equal to 0. So that's our first move. Let's move the x to the third to the left side. So I'm going to add x to the third to both sides. Our equation needs to be written in standard form. X to the third plus 5x to the second plus 6x equals 0. Now that we have the equation in the correct form, we can start factoring. Again, always look for GCF first. These three terms have an x in common, so I'm going to take out an x, which leaves us with an x squared plus 5x plus 6. Now you pause here again and you examine what you have. You go, wait a minute, I have a trinomial that is even. So yes, that calls for the x method. Product is 6, sum is 5. Product and sum. A times C and B, just for those who need a quick refresher. So what multiplies to 6 and adds to 5? If you've said 2 and 3, you are correct. So now we have the factors that we want. Bring down the x that you factored out at the beginning. Don't lose your GCF. Keep bringing it down with you. And then now this becomes x plus 2 and x plus 3. However, remember, we were being asked to solve. So we have to then take the extra step, set each of your factors equal to 0. This one has 3 factors. This factor, and that factor. And each of these will have to set equal to 0. So the first one is pretty simple, x equals 0. Second one, x plus 2 equals 0. Third one, x plus 3 equals 0. To solve for x in these two, subtract 2 from both sides, subtract 3 from both sides. So now you have x equals -2. Here, x equals -3. So your 3 answers are x equals 0, x equals -2, and x equals -3. 3 answers. Question 57. I'll change the color here for contrast a bit. Okay, this is a difference of 2 squares. So we have to factor first. Remember, with the difference of squares, you get 2 parentheses. One's a plus, one's a minus. X plus 6, x minus 6. And you're solving, so you're going to set each of these equal to 0. X plus 6 equals 0. X minus 6 equals 0. Just use algebra because you've done this so many times. I'm kind of breezing through this. Subtract 6 on the first one, add 6 on the second one. So boop, boop. X will ends up being -6. Here, x ends up being +6. So your 2 answers are this and that. Next question. You have 4 terms. So which method should you use here, folks? If you've said grouping, you are correct. But first, I feel like we should take out a greatest common factor. Always look for GCF first. And I'm just realizing that all of these have an x. So we should really just take out the x first. That's the GCF. So that gives us x to the third minus 5x. Ooh, it's actually out of order. So first things first, this thing is out of order. It's not in standard form, so be careful. So I'm going to bring this guy here, and then this guy's going to come over here. So it'll be x to the third, and then this here will be minus 4x squared which makes this guy here minus 5x plus 20 equals 0. Yeah, so that was sneaky. Y'all be careful, folks. So now we go, great. You've taken out the greatest common factor as we should. That's what we always do when you have, an expression. An equation that you're trying to solve for. Take out GCF. And then once you've taken out GCF, examine what's left in the parentheses. So we have 4 terms. I'm going to group these two together and group those two together. Don't forget that the original GCF that you took out, don't forget it. Usually I draw an arrow so I don't forget it and just have it down here. So that way I'm not dragging it with me the whole time. I just don't want to forget it. I'm going to put it out there. So the first parenthesis, this one right here, we look closely and you go, oh, we can take out a GCF for those guys. They have an x squared in common, which leaves us with an x minus 4. The second parenthesis, these two, have a negative 5 in common, which means we can have an x minus 4 left. And now to see these two outside terms, we put them in their own parentheses. So we end up having x squared minus 5. And you bring down one of these, so it's x minus 4. That's fully factored. But since we're solving, we have to set each of our factors equal to 0. So the first one is this one. So x equals 0. That's done. The second one, x squared minus 5 equals 0. The third one, x minus 4 equals 0. Then we got to solve for these. So for this one, I'm going to add 4 to both sides. So the 4's, of course, cancel. So we end up having x equals 4. The second one, I'm going to add 5 to both sides. So now these cancel. We have x squared equals 5. But we don't want x squared. We just want x. So you have to square root. And we end up having x equals plus or minus square root of 5. So we have 4 answers to this question, as we should have had 4 answers. Why? To the 4th power means we should have 4 answers. Well, what are those answers? You probably are asking. X equals 0, 4, and plus or minus root 5. Those are the 4 answers. 1, 2, 3, 4. That would be your answer to that question. Okay, on to the next one. We're going to keep working through these. Again, always take out the GCF first. Big rule. The leading coefficient should never be a negative number. So what you want to do here is, why don't you take out a negative 1 to force this to be a positive? So this becomes x to the 3rd. And of course, that's going to affect all the other signs also. So change the signs for all of them. In fact, let me pause here. Let me see. I just see they have something in common. They have an x in common. So let's take out a negative x, actually. That leaves us with a positive x to the 2nd. Change the sign to negative 4. You took out one x, so it's negative 4x. Change the sign, so it's going to be a minus 21. You took out the x, so that's it. And of course, you want to pause here and examine what's inside of the parentheses, right? Here. It's a trinomial that is squared. So the x method makes sense. Product and sum. Product is negative 21. Sum is negative 4. Right? So we know that we can factor, we're looking for numbers that multiply to negative 21 and add to 4. If you're thinking 7 and 3 with a negative 7, you would be correct, because negative 7 plus 3 is negative 4. Negative 7 times 3 is negative 21. So this becomes negative x minus 7, x plus 3 equals 0. You're setting each of your factors equal to 0. So that's going to equal 0. X minus 7 equals 0. And x plus 3 equals 0. Now you've got to solve for each of these. This first one, divide by negative 1, because there's an invisible 1 here. This second one, you're going to be adding 7. Third one, you're going to be subtracting 3 from all. So look, here. Our final answers are as follows. Those are gone. X equals 0. X equals 7, x equals negative 3. You can write the answers like this, or just like in the previous problem, you can just put them in one straight line, like x equals negative 3, 0, and 7. Whichever one you prefer, either one's fine. Okay, question 60, very similar to the previous question. Do we have a greatest common factor? The answer is yes. X in common leaves us with x squared plus 8x plus 16 equals 0. So this part is factorable, right? So x, again, use the x method. At this point, I'm just going to keep going. It's x plus 4 and x plus 4 because you guys know how to do the x method now. Oh, notice these two are exactly the same. You don't have to solve for both of them, honestly. So we'll set each factor equal to 0. And since the x plus 4s are the same, I'm only going to solve for 1, right? So I'm going to subtract 4 from both sides. These cancel. So x equals 0 and x equals -4. For those of you who may be wondering, what about the other one? This is where the multiplicities came in, folks. If I have two x plus 4s, I could say the answer is x equals -4 with a multiplicity of 2 because there were two of them. This would be x is equal to 0 with a multiplicity of 1, in case you're wondering. But, there you have it. Did the question, did these even state the multiplicity or not? Let's actually look at that. No, factor, solve. It didn't. But in case you're wondering, that's where the multiplicities came in. Okay. Now here we are determining if its divisor is a factor using synthetic division. Here's how you know that something is a factor. If your remainder equals 0, then you know that that divisor is a factor. So let's set this up, synthetic division. Once again, remember, you got to solve for it, this thing. So it'll be -5. The coefficients are 1, 2, -22, -45. Always drop the first number first down. So it goes down here. Then you multiply -5 times 1, -5. Then you add 2 minus 5 is -3. -5 times -3 is 15. Then you add these. -22 plus 5, I believe that's -7. -5 times -7 is +35. When you add these, you get a -10. Oh, so sadly, you did not get a remainder of 0. That's neither good nor bad. It just means that x plus 5 is not a factor. That's your answer. Or you can just say no. Had we gotten the remainder of 0, then the answer would have been yes, but we didn't. We got a -10. So there you have it. And that's what we're going to do for the rest of these. I'm going to change the color here so it's not so monotonous. Instead of the synthetic division, a 1 goes on the outside. 1, 2, -5, 3, -1. Drop down the 1. Multiply, add. So here you get a remainder of 0. So the answer to this would be yes, because we got a remainder of 0. Here, repeat the same process. Synthetic division. 2 goes here. 1, 5, -14. Drop down the 1. Add 0. Oh, guess we got a remainder of 0. So you would say yes, x minus 2 is a factor. Here, it's kind of getting boring at this point, right? So bear with me. 1, -3, 2, -4, and 4. Drop down the 1. Multiply, add. Remainder is 0. So this would be yes. Okay, this is, notice here, we're missing a bunch of terms. We don't have x to the second. We don't have x to the power of 1. So we need placeholders. Just as a reminder, -1. So we have a 2 and -1. We're missing x to the second. So I'm going to put a placeholder. We're missing x to the power of 1, putting a placeholder. And then we do have a constant as a 4. So drop down the 2, multiply, add these guys. -3. Oh, yeah, this becomes a -3. -1 times -3 is a +3. The remainder here is a 7. So this is no, not. Okay. The next portion is asking you to find all the solutions of this equation given that x plus 5 is a factor. Sure, not a problem. Here's what you do, folks. you start off by using synthetic division. So we put a -5 out here because of this. Then the coefficients are 1, 5, -3, -15. Drop down the first digit. Multiply, add, multiply, add, multiply. The remainder is 0. That doesn't surprise us because we knew that this was a factor. We were given that. Now, if you want to find all the solutions, you now have a new equation here. Remember, these are your coefficients. So this is now x squared plus 0x minus 3 that you need to solve for. These are your new coefficients. And remember, when you divide, you came from x to the third, you drop the degree by 1. So that's why we have an x squared. By the way, is there a point of me writing x 0x? It's kind of silly, right? So when I eliminate that, and what we really have is x squared minus 3 equals 0. We have to solve, says find all the solutions. So that's why I'm setting it equal to 0. And we can solve this using the square root method. So let's just add 3 to both sides to that, right? So what's going to happen? X squared equals positive 3. And now we can square root both sides to get x by itself. So we end up having x equals plus or minus the square root of 3. So the solutions to this are -5 that came from what we were given when you solve for x. And then we now have plus or minus root 3. We should have had 3 answers because x to the third. And we do have 3 answers. Here's the first one. And then here are 2 answers, positive root 3 and negative root 3. Okay. Next question, very similar to the previous question. You're given 2 numbers that are solutions. This time, we don't have to solve for them because, let's just use one at a time. We'll start off with, the 1, I guess. And then the coefficients of this guy, which are 1. Ooh, we're missing x to the third, so placeholder. We have x to the second is a -9. Oh, we're missing x, that's a 0. And we have the constant. So we were missing a bunch of things here. That's why we have those zeros there as placeholders. Drop the 1, multiply, add, multiply, add, -8, multiply, add, multiply. So this ends up being a 0, which we knew because, we were given that's a solution. So we've spent this one already. So now we repeat this using the other thing that we were given, which is a -1. We're going to continue the synthetic division. So I'm going to just continue it here. Now we have a -1 on the outside. We're using the second one now. Okay, so drop the 1, multiply, add, and then multiply again, add, multiply again. Again, that's a remainder of 0, right? Good. So now we've spent the 1, we've spent the -1. We want to find all the roots. So remember this, each time you've divided, every time you've divided, you have brought the degree down. So we started to the 4th power. This is when we divided the first time, it brought us to the x to the third. The second time, we now add x to the second. So these are the coefficients. We now have x to the second plus 0x minus 8. But again, 0x doesn't make sense to have here. So I'm going to rewrite this as x squared minus 8 equals 0 since we're solving. And to finish this, of course, you're going to solve for x using the square root method. Add 8 to both sides. These are going to cancel. X squared equals 8. And then you got to square root both sides, right? Square root and square root. And we've already done how to, square root these guys, but it'll be x equals plus or minus. The square root of 8 can be simplified to 2 root 2. How? Square root of 8 breaks down to, 4 times 2. Oh, 4 has a square root, so that's going to hop out. The square root of 4 is a 2, root 2. That's how we got this answer. Now, since we are being asked to write all the roots, we got to list all the roots. So the first answer, the ones that we were given were -1, comma 1. Those came from the question. They were given those as roots. And then we just found 2 others, plus or minus 2 root 2. 4 answers, which we should have had 4 answers, and we do have 4 answers. Okay, y'all. Well, we have just 2 more questions. Bear with me here. We are almost done. Okay. Then we've got find the other zeros, given that -1 is a 0. So again, starting off with the synthetic division, -1. Coefficients are 1, 2, -1, and -2. Drop down to 1, multiply, add, multiply, add, multiply. The remainder is 0. So now this brings us to x to the second plus x minus 2. Now we try to solve for this using, it's a trinomial that is squared. So we're going to try using the x method. What's the product? What's the sum? Product is -2. Sum is 1. What multiplies to -2 and adds to 1? If you're thinking 2 times -1, then you'd be correct. So now we know that we can factor this guy to x plus 2 and x minus 1. Since you're solving, you're going to set each of these equal to 0. So you've got to subtract 2 from both sides, add 1 to both sides on the second one. And then these cancel, so x ends up being -2. These cancel, x ends up being a +1. So all the zeros would be x equals the -2, -1, which you were already given over here, and 1. I like writing them in order from the least to the greatest, but there you have it. Last but not least, folks, for this question, we are given that x minus 1 and x plus 3 are factors. So if you're going to use this in the synthetic division, remember you have to solve for each one. So this we'll have to use, a 1. So we'll be dividing by a 1 in the synthetic division for this guy. And here we'll be divided by -3. It'll be 2 back-to-back synthetic divisions. Well, let's set them up. You've got here. Let's start off by dividing by 1. This will be x equals -3. So let's divide by 1 first. It doesn't really matter where you start, but I'm just going to decide to do this one first. So the coefficients are 1 and 1, -11, -9, and 18. Drop the 1. Then you multiply, add, multiply, add, multiply, add, multiply, add. The remainder is 0. But that comes as no surprise to us because we were told that those are factors, so we knew they would work. Now look at the second one here, which is the -3. That's the one we're going to divide with next. I'm going to put it over here. Now we're dividing this by -3. Again, drop the 1, so multiply, add, multiply, add, multiply, then add. Again, the remainder is 0. That should not come as a surprise because, again, we knew that was a 0. So here's the new equation. These are the new coefficients. We started at x to the 4th. We've divided twice. So the first division brought it to x to the 3rd. The second division has brought it to x to the 2nd. So this is 1x to the 2nd minus x minus 6 equals 0. A trinomial that needs to be factored, well, x method. So let's do the x method here. What multiplies to -6 and adds to -1? If you're thinking 2 and -3, you'll be correct. Those are the factors that we're going to be using. So this factors to x plus 2, x minus 3. Since we're solving, you're going to set each of these equal to 0. X plus 2 equals 0, x minus 3 equals 0. To solve for this, you're going to subtract 2 from both sides. You're going to add 3 to both sides. So you end up having x equals -2 and x equals 3. So to write the final answer here, just find all the zeros. I'm going to say x. I'm going to list them all. So I'm going to write them in order from the smallest one to the greatest one. You don't have to do that, but I like doing this. So the -3 is our smallest one. Then we go to -2. Then we have a 1. And then we have a 3. Those are all the answers that we have. X is 1, -3, -2, and 3. And that, friends, completes this review. Hang on, let me see if I can restart my camera. Oh, I can. There we go. Okay, folks. So that brings us to the end of this review packet. However, remember that this is not limited to just these things. There is this other unit, the last unit that we were working on with characteristics of functions and behavior, like intervals of increase and decrease. Those aren't on this packet. But since it's so recent, the idea is you have them in your mind because you actually have a test you just took a test on this, so they should be pretty fresh on your mind. Remember that you do have your respective teachers available to you during the review sessions, like the review days, and also before school and after school. So thanks for following along. And just feel free to reach out to those teachers or just refer back to this video as many times as you need. Thank you for being awesome students this semester. I wish you a very Merry Christmas and a Happy New Year. I will see you again in January. Take care, folks. Adios.